Hello again and welcome back everybody. Hope you got your coffee on this Friday afternoon and that we are going to go into our next session. You are in for a treat and this is one I've been looking forward to personally for the last 2 days really. Professor Rozenn, she is with us from Professor Rozenn, I hope I get this right, Dahyot from Trinity College Dublin, and correct me if I'm wrong because as you can imagine with Radine I get all sorts of names as well, and she is also working with the ADAPT Research Centre. Rozenn is working on statistical pattern detection and recognition, image and video processing. So today she's going to talk about digital twins for sustainability, and when she explained this to me she kind of made it very accessible. So she framed it in the way that if you had a virtual replica of your city or space, how would you make it better? And I thought this was a great question because it's something that we can all really identify with. So another Menti poll question, because we love to hear from you. This is the simple question. So if you had a virtual replica of your city or space, how would you make it better? If money wasn't an option, if you could do what you wanted, how would you fix it so it works and functions in a much more fluid way, that it would be a space you'd want to exist in? And that's the exact kind of work that Professor Rozenn is doing. So if you go to menti.com and you use the code 530997 and enter your answers. I'm going to do the same here. So just take out your phone, go to menti.com and put in the code 530997. Okay, so these are the kind of things that are going to come in. So smaller buildings is a really interesting one. I think we're going to see a lot of that, like more green space, more social space. It's one of those things, the first thing you think about when you think about your city or space, that you want to have that connection with nature. And there's never been a time where we've needed and wanted that connection more than right at this moment. Less traffic, so closer to work, and maybe our current situation will accelerate all of these things. Collaboration, support, community. Less traffic, I think, is a big one. More social areas, safer streets, less pollution, parks, intersections, horizontal gardening. Oh, interesting. Remove litter. I didn't even think of litter. Yeah, of course. Fewer mistakes. Yeah, that's all encompassing. Great. Underground transport. Given that we've decided we're not having the flying cars, which is, no cars at all. Oh, wow. Oh, this is, improved infrastructure, pedestrianization, streets, okay, restricted construction, cycle lanes, drone taxi. You guys are on the ball today. Reduced crime, places to meet. It still feels very much that community is going to still galvanize us, which is really comforting. Okay, community support, social areas, sustainable transport, happy space. Oh yes, please. Improved safer streets, places to meet, less pollution, better drainage, lower density housing. Okay, because then you have tons there to work with. So I'm gonna pause that there. And stop sharing my screen. Great. Okay. So without further ado, I'm going to hand you over to Professor Rozenn Dahyot.
Thank you very much, Radine. Thank you very much for this invitation. So I'm just going to share my slide. I hope everyone is seeing my slide here. Thank you for the invitation to this John McCarthy AI Summer School. So what I'm going to present is basically research that has been done in my team for the past 5 years, done in Trinity College in collaboration with the ADAPT Center, as part of different projects, from EU project to nationally funded project here in Ireland. So digital twin for sustainability. I will first explain a little bit what is digital twin through several examples of past projects. Okay, so this is my first slide showing a few examples of application and the type of data I have been looking at. So the first example is drone capture that has been done in Trinity back in 2017 in collaboration with Intel and Movidius. We collect images from drones, so the view from above for Trinity College, and we use those images together to provide a 3D model of the campus. So one standard application of creating a 3D model is, for instance, for virtual visit, for instance. That's one application. But if you think of a 2D map that you use quite often to find your way through a city, then a 3D map is just a natural extension. In particular, if you think of having a drone that is flying autonomously in the city. So this is one example of using AI for creating this 3D model. And what we did with that 3D model was to put it in conjunction with OpenStreetMap, which is an open source website that people contribute to create a 2D map that is very, very informative. So it's created by users. Doing this, we can actually put labels onto those buildings. So being able to give their names from the map automatically. So putting together different stream of information such that they can create even more useful information for users is one aspect of the research that I'm doing. The second example of data that we have been using is social media. So everyone is familiar with Twitter and Instagram, for instance, and really you are capturing what is the feeling of the people on the ground, what they think about their city and what is it that they are saying about it. And in particular, what are the areas of the city that capture their attention. So usually if you like something in the city, you're going to take a picture about it and then comment about it in your tweet. In tweets, you do have as well the aspect of geolocation associated with the media you are providing. The third example of data that we have been using historically is Google Street View imagery, which is very accessible as well through API. So the same as Twitter, you can access those data through API. So it's very well designed. There is the data, but this data is also accessible. So we use those type of data to create 3D model of a city. So on the left-hand side here, we use WebGL technology to create a 3D point cloud of the Trinity campus from the drone imagery. Here, we decided to use information from Twitter. So if a user is actually tweeting several times during the same day, it is creating some sort of GPS tags over time during the day. And therefore, we can create somewhat a trajectory of those users on Twitter. So if we have to train cars to be able to drive and to avoid pedestrian, it would be good to have virtual environment with a virtual pedestrian that simulate similar behavior of real pedestrian. And to do that, we need to capture data. And Twitter was somewhat providing a sort of proxy to that type of behavior. In the last example here, we have used OpenStreetMap in combination with Google Street View to create a 3D city. So here, this is an example of Pittsburgh. It has been put into a game engine that is called the Unreal Game Engine. And we have created those 3D representation to visualize the activity on social media. So the lights that you see appearing across the city are in fact a tweet where there is an image that is showing those particular buildings in the image. When the color of the light in the virtual environment is blue, it means that the sentiment associated with the text in the tweet is pretty gloomy or sad, if you like. If the light is more yellowish, it means that the comment was more positive and more happy, if you like. So we can really capture what people are thinking about their environment. So one type of application that we thought of at the time of that research was if you land in a new city and you don't know where to go for cultural activities, then you usually go to the tourist information center. But the tourist information center, there is a lag in terms of the information that they have and the actual interesting spot in a city that you may capture through social media. So people are really reacting very quickly and provide up-to-date information. So that was a way to kind of capture visually all that information that was feeding through social media. So in those research, we use different type of imagery, so street view imagery, IIL imagery from drone, as well as text information for capturing sentiment, the GPS tags associated with all those media. So when we talk about a virtual replica or a digital twin, we reference to something that really replicate the real environment that we are in, and in other words, everything is actually geolocated in those environments. When we talk about game engine technology, this is not something new. It has been there for quite a while, but it was mainly used originally for the game industry. But we now see that it is quite useful for creating simulated environments like digital twins. So I talk about maps as well, like OpenStreetMap. How can we augment information from OpenStreetMap? So maps historically come from geographers. So this is another domain, and usually historically as well, that was in 2D that those maps were designed. So extending to a new dimension of 3 dimension, but over time, then you have 4 dimensions. So it's very important to keep up-to-date maps, in particular for autonomous driving that was addressed earlier on. Okay, so another example of an application of my the research in my team is how can we use a satellite imagery, for instance, so IIL imagery that might be available to capture the extent of damage after extreme events, weather events. So here, this is an example of flood, and the work was in response to a challenge that was put to academics. So a dataset was provided by to academics to try to detect flooding events through satellite imagery in combination with social media imagery. And in particular, what was of interest was to detect if the road were passable. So can you drive through the road even though there is a bit of water on top of it? Or do you need to take a boat because the car cannot manage that? So using social media street view imagery, you can somehow capture if a car is able to pass through the road or if really you cannot manage this to happen. So using those two information in combination, IIL imagery and social media imagery, then you can somehow make a decision if a road is passable or not. And that can be very important if you deploy emergency services in areas that we need to have some appropriate transportation like a boat or a car. So what sort of technology are we using to do that? So of course, artificial intelligence is at the heart of it, and in particular CNN. So CNN is convolutional neural network. So a lot of things that we hear today about AI is really about neural network. And when it comes to images, there is a lot to do with CNN, convolutional neural network, because the operation, the mathematical operation of convolution is actually very efficient when computed over images. So images is a very regular 2D grid of data. So that's a 2D array of data, if you like, and it's very well managed by a convolutional operation. So it's very suited for this type of architecture of neural network. So in that work, we were using those CNN to extract features that are relevant to understand the scene coming from social media, as well as the scene coming from aerial imagery. And fusing all the information from those two streams of data, then we can get an accuracy for deciding if a road is passable or not up to 60%. So the 60% is also capturing that there is a lot of noise associated with social media data. Okay, so it was not originally designed to for this type of application, but people are using it really to comment about what is happening in their streets. So that's very useful in that context. Okay. Solar energy. So when we talk about sustainability and resilience of cities, we want to be able to produce electricity such that it is sustainable, and solar energy might just be one way for doing this. So here, this is a work that was in collaboration with Ordnance Survey in Ireland, where Ordnance Survey is collecting aerial imagery for the whole country of Ireland and different level of resolutions. And the question that we were asked was looking at inferring height automatically. So for every pixel in the aerial imagery here, we want to infer what is the height of the building. Okay, so we want to design an AI that is able to give a height for every pixel in the image. But to train an AI, you need to have access to data. And this is what I'm showing here. This is another source of information that is open source that was collected as part of an ERC from one of my colleagues in UCD in 2015. And that was a very high resolution LiDAR scan of the Dublin city centre. So using this information from the LiDAR, we were able to create a training data set to match the aerial imagery provided by OSI, such that we would be able to create a training data set for creating an AI that would be able to infer that height automatically. So you see an example of result here, displayed as a heat map, inferring the height above ground. Mainly, this is where we are interested in the infrastructure, so mainly buildings, but you also see that we capture trees as well in the landscape. So once we have that, it's quite crude because the resolution of the imagery is relatively crude as well. So it's the order 50 centimeters by 50 centimeters. Sometimes it goes down to 20 centimeters by 20 centimeters. So every pixel have a real resolution in the physical space. So you need a little bit further processing that is available inside Geographic Information System, GIS. So here we use a post-processing module available in ArcGIS, and to try to fit the shape of a roof a little bit more accurately beyond what the CNN was able to do in terms of providing the shape of the roof. So you see here the difference in between what we are able to capture with LiDAR scan versus what we're able to recover from imagery. It's not the same quality, but capturing LiDAR is way more expensive, and you can only do that on small area of a city, and you cannot do that for the whole country. So that's the benefit of using aerial imagery or satellite imagery, is that you have a much bigger coverage. So what's the point of knowing the shape of roof? Well, before you go on putting solar panels, it might help you to tell you how to put them, or if you might need to upgrade the roof to optimize the orientation, for instance, to maximize the solar energy potential. Okay. So here, this is an example of an earlier project, circa 2017, that we did in collaboration with the telecom company Air. So we were asked to actually devise an artificial intelligence to find all the poles in Ireland. And for this, we had to decide which data stream would be useful to do that. And a pole was actually very difficult to see from above, from an aerial imagery. So we settled down with using Google Street View imagery, which has a large coverage, but still is missing some spot. But still, that was the one that we chose because it has a large enough coverage for doing what we had to do. So Just an example here of this video, we devise an AI to detect those poles. The image associated with Google Street View are also associated with an orientation north-south. It's also associated with a GPS of the car taking the picture. But what we wanted to find was the GPS tag of the pole appearing in the image. And sometimes a pole is appearing several times in several images. So what we want at the end of our system is a complete list of the GPS tag of the poles that are there, but we don't want duplicate in that list. So that's very important in terms of managing information there. We don't want to have noise in the outcome provided by the artificial intelligence. So artificial intelligence, if I take the expression intelligence system, then we use CNN in combination with a statistical technique called Markov random field to do some fusion of information there to be able to provide a list of unique objects of the asset that was to be discovered. This technology is actually under further research there for finding commercialization avenue. There is a lot of demand in terms of finding infrastructure or geotagging infrastructure to augment the information available in maps. So poles are very important, in particular for providing the internet that we are all relying on at the moment, but also for future development and for managing any kind of work you might have to do after a weather event. So here, this is just an example of what you do with the information provided by such an AI that is able to locate your asset on the ground. Then once you have this list of those assets, you can interface that list very easily with other geographic information system. And here we have an example using Google Earth. So this is a screen capture from an iPad where you see where the poles that have been detected are. And this animation is just showing how you can use your map interactively to actually see what is your asset. So here we have click on a pin, it's telling you that the data that has been captured in Google Street View is from 2019, and there you see the poles is in the middle of the image. So the user can actually check the result of the artificial intelligence. So even though we have very high accuracy in terms of detection rate, obviously, there is always a few mistakes there and there, and the human user at the end can always check the result. It is also important to keep track of the date of the capture of the data, because if the image is too old, let's say if the image was from 2010, then the pole might have disappeared and might have been replaced by something else. Okay, so that's an example of the technology that we are currently deploying as part of this project AIMAPIT that is supported by a commercialization fund with Enterprise Ireland at the moment. Okay, so what is the type of research we are doing? So we are really looking inside the artificial intelligence and try to make it more efficient. So one of the problems of neural network, it is very angry in terms of the data set you need to provide to train your machine. So we try to make it more usable, in particular for startup company who might not have too much data available yet. How can we train those very powerful machinery with small training data sets? Another area that we are working on is trying to compress neural networks. So how can we use tricks from mathematics to make a neural network a little bit smaller? Smaller meaning having less computation, less parameters to tune, less time to actually train the neural network, and a neural network that is smaller to cast onto an embedded device, for instance. So all this is very important for Internet of Things or having artificial intelligence on the edge. Neural networks don't do everything. You always need to cater for the data that is used. So some pre-processing process are needed. And in particular, denoising, so trying to limit the effect of changing colors, for instance, if you are dealing with images. If you have preprocessed for removing some noise available in the GPS, then that's also very useful. The better the quality of the data that you use to train an AI, the better the AI is going to be at the end. Also, as I presented several intelligent systems here, neural network is just one block of those intelligent systems. So we are still looking into ways to integrate more prior knowledge coming from different fields like physics. So if you think of game engine, they were using the laws of physics to actually animate objects in virtual environments. So if you play games, for instance, the character cannot walk through a wall because physically you cannot do that. So how can we use the laws of physics to improve even better artificial intelligence, and in particular remove this computational load associated with machine learning technique that only rely on the availability of data. So Internet of Things here, how to put the AI onto the sensors and the end of the line. That was one of the topic of the EU project Bonsai, and Trinity was one of the partner on this project. So that was a big project that was led by Enviso in Switzerland, and part of the problem was trying to devise a way for companies to be able to port their artificial intelligence from a standard computer or the cloud onto a smaller device like a Raspberry Pi. And you have different frameworks that are proposed for doing this, and they all have different performances. So here in our research that is published now, we were showing the performance of our framework called LPDNN that is in green on the chart in comparison to other framework for porting the artificial intelligence onto Raspberry Pi and those different Raspberry Pi 3 and 4, and showing that we were having speed up using our technology that was developed as part of the Bonsai project. So to have AI on the edge, one of the advantage, if you think of Google Street View, it is not authorized to have Google Street View in some countries, and that's for privacy concern. So if we go and collect imagery on a regular basis, people might be concerned about this aspect of data collection. So what if we can process the image on the go and never store the data explicitly, just detect the pores that you need to detect in the image, and you just need to feed that back onto the cloud for further processing, but you don't need ever to actually transmit the image or keep the image. So that might be a way to deal with privacy issue, is to have this AI on the edge. Okay, so one of the talk yesterday from my colleague John Kelleher was mentioning that neural network is having a footprint, carbon footprint, and in particular this publication from another team was mentioning this carbon footprint in comparison to other things like air travel or using a car. So digital twin for sustainability, or is it sustainable to have digital twin? So the answer to that might just be solar energy for producing the energy necessary for the neural network. That's one way to go about it. But also there is a lot of effort in terms of rethinking neural network as part of a bigger mathematical framework that would be more computationally efficient to reduce that carbon footprint. So a lot of effort in that direction. So here, this is really the last slide that I wanted to show, because literally a few days ago, this YouTube video was posted on YouTube, and this is a very, very nice video on how to China clone Shanghai. So they are using the same as us 5 years ago, the Unreal game engine. They are using IRL imagery. They are using LiDAR scans. They are using 3D imagery to create a full replica of a city like Shanghai. And you have also examples from other parts in the world. So there is example in that video of New Zealand having an effort as well for digital twin. And that video is concluding with digital twin are still in their infancy and have an enormous potential for application. And one application that was mentioned earlier today was autonomous driving. And before you put a car in the real environment to drive on its own, for everyone's safety, the best is actually to have a duplicate of this world and to have the car training in those digital twin. And so that there is an optimization there in terms of limiting accidents, for instance, and have scenarios where we can mix real drivers with AI drivers. So there is a lot of advantage about using those digital twin. So of course there is application in city planning and mapping, creating virtual visits and attract more tourists. Coming to your city and providing some digital portal for people to discover the areas. There is of course avenues with entertainment like augmented reality and virtual reality, and in particular one thing that is going to be very important in our city is to have a very pretty city that is not making people depressed, because we have to live in the cities. And one thing that has been occluding our space, for instance, is advertisement in streets. So maybe augmented reality would provide a way of having overlaid advertisement that doesn't crowd the physical space that we have, and putting the advertisement elsewhere in the digital world. Education is also very important. We need to make people aware of climate change and population growing and all those issues that we have to tackle. Digital twin provide visualization of those effects. And it has been used efficiently for the movies industry. And I have this example of this movie from 2004, The Day After Tomorrow. In the same movie, New York is flooded and then is completely snowed in. So this is probably extreme, but the visuals that are created are really speaking for citizens and decision makers at the end of the day. So in terms of education and preparing people to different scenarios, it's actually a very useful tool. For transportation, as I mentioned, it can create a very nice environment for training artificial intelligence, and for creating an environment where it's much easier to actually monitor your infrastructure. So we are looking into assets for deployment of 5G, for instance. People want to be connected with the internet, and with this current pandemic, the internet has become very important for being able to have those virtual experience with this school that is online right now. So we need to have a way to keep track of this infrastructure, to know how to replace this infrastructure, and again, to keep this environment up to date for the users at the end of the day. So monitoring the environment and keeping track of the biodiversity is also very useful. So the example about pole detection, in fact, the same technology can be used for mapping trees in cities, and this is also an object of interest in cities, is to monitor trees and try to keep track of the biodiversity in cities. I gave an example of how we can use all those media maybe to inform about events like floods and how to react, how to survive this impact of floods, and how to manage those events that might come back at a regular basis now. So these are the few examples of the things we have been looking into, and one of the difficulties that we are encountering is having access to data that facilitate this kind of research. So I mentioned social media data, satellite imagery, IIL imagery, Alaska, and drone footage. And to have this ecosystem where all this data is available can be quite useful for providing AI researchers a way to move forward with those things. So that was more or less the content of my talk. So thank you for listening, and I'm very eager to hear about your questions. And just mentioning this conference that we're organizing in a year time now in Dublin that is about signal processing, and signal processing is really behind artificial intelligence today. Thank you very much.
Rozenn, that was excellent. A fantastic showcase of some of the really, I suppose, what I would have perceived as quite futuristic, but it's all here and happening. So applied AI in the world we currently operate in. One of the things that really struck me was you can now harvest the social media data to understand how people are using their space, but also emotionally engaging with their space, which is huge. We've had a lot of questions coming in, so I'm not going to take up any of your time. I'm going to divert right to the audience. So Robert came in and he's like, amazing, you've got a lot of fans in the crowd, which is good. So his question is, do you think computer vision models in cars will ever be good enough to map replacing LiDAR and pre-tagged GPS maps?
So it is not replacing, it's used in combination. In fact, the more redundancy you have, the more reliable your system is going to be. And this is why I'm talking about designing a map, because if we share a map about, how things are, that gives already a lot of clues about, what's going on. Just having the GPS of the car, what is going to be around you, right? Even without cameras. Right now, you can add cameras, and cars now have a combination of RGB or standard image, right? But they also have thermal imagery to be able to detect pedestrian more efficiently, for instance. And they have some sort of LiDAR technology that is a more active sensors that bounce back if there is obstacles around. So they have different type of sensors on board. And that's going to be very important to design cars that are resilient to a sensor that suddenly is not working, or simply a camera that is occluded by a little bit of mud, for instance, right? So this is really having an intelligent system that is resilient with something failing, and this is something quite standard for designing planes. You have redundancy in the system to make them reliable. So yeah.
So it's there already, even in theory. Yeah.
Yeah.
Okay.
Yeah.
Great. We have another question in. Fascinating research. Again, big fans. What are your thoughts, Rozenn, about using digital twins for analysis of human anatomy?
Yes, so that's an interesting question here. So that's another area that I have a lot of questions from my colleagues, is to look at AI for medical imagery. And exactly here I'm showing an example of maps, and this is looking at the planet. But if you think of the human body as, the space you want to represent, then that's funny, because every human being is a different planet, and we need to localize, the problem associated with disease, or where the things are wrong when something is wrong for medical applications. So yes, this type of technology can also be applied for helping medical experts for their diagnosis. So we are looking at different type of imagery there, which come from a medical expert. Did I understand well the question?
Yes, I think you did. And I suppose from my side, just so I understand, so if everyone's individual and you're recreating the digital twin of the anatomy, it would be a recreation of every individual digital twin of an individual. Am I right in that?
Yeah, so at the moment you do have digital replica of the human body. This is used for training doctors, so they have access to AR, VR, and 3D models, such that they can learn where the bones are and where they're, what they learn in medical school. But there is always subtle changes from one person to another. So you cannot have an average human that is going to be good for everyone. So this is why I'm talking to these fine-grained subtleties there, that we are slightly different from each other, and therefore, if you want to use that for helping the diagnosis and help you for your health, then it might need to be fine-tuned to yourself a little bit more, right?
Makes perfect sense. Actually, quite a related question in from Suman. Can you please share your thoughts about the digital twins for cattle and farming, and how can we apply this?
Cattle and farming. So, well, I'm guessing you can. So aerial imagery is used for kind of tracking the crops, right? And the growth of the crops, particularly if you cannot monitor every area, if you have very large coverage for your crops. For cattle, I am not quite sure how this can be used, maybe for tracking the cattle and try to detect if there is stress level, because we know that when the cattle is stressed, it can affect the quality of the milk or whatever cattle produce. So the well-being of animals, computer vision can be used for that sort of things as well. So if it can be used for humans, it can be used for animals. Social media is full of cats and dogs.
And that tends to be what does very well. Actually, speaking of social media, so talk to me about how you're addressing, question came in, how you're addressing the GDPR issues around collecting data from social media, people messaging from populating visual cities using social media. So going back to what I was talking about earlier, how are you navigating the GDPR elements of that?
So GDPR came later than some of the projects that I have shown, so maybe it was a little bit different when I did that research. I would just say that this data is actually visible by everyone, which is something I like. Even if you're not a Twitter user, you can see it. You're not prevented from seeing it, which is different from other social platform, which is, you have to be a user to actually see things. And you might not see the same thing as someone else on that same social media platform. So in a way, everyone has access to that data from social media. And when it comes to the research we do in academia, it is published. So in other words, there is a discussion about the potential dangers of those data and using artificial intelligence associated with it. So that's the difference in between maybe an open research where, this is in full sight of what we do is always presented as not a problem, it's not hidden, versus what maybe some companies might be doing with their AI and their social network. So that's a big difference. We need to be open-minded to the idea that sometime we are going to discover things that we are not going to like, but that's going to be the trigger to generate a law to protect citizens. As long as everything is in full sight, I think we are okay. So some of the data set that we have used in our later research is actually designed for research. So it has been collected in full agreement of everyone involved, and all the researchers are playing against these data sets.
Okay, that makes perfect sense. I suppose one of the questions that has come up is around the digital twinning and how we use that for ensuring people can have access to buildings, so wheelchair accessibility, creating spaces for people that are aging.
So that's very interesting, because that's the sort of things I was very interested in. I'm very clumsy. I don't need to wait old age to kind of fall around. So I'm wondering, why is it that there is a 10-centimeter step for the pedestrian passing between the road and the pedestrian? So all this is kind of tricky to move around. So yes, hopefully we will have as well fine-grained information coming from street view level. Actually, the autonomous driving companies have a momentum to have a digital map that is 3D with the centimeter precision. This is what they are looking at. So to see all those accessibility issues for people having a wheelchair, or even people with buggies, and accessing buildings. So buildings are more associated with the building industry and the BIM format that is used in that industry. And the idea is to bring that in as well. So not only you can see the outside of the city, but you can actually get in the city and have this virtual experience. So with the pandemic, there has been a lot of move into creating those virtual experience where we can reproduce the office experience. And so that can be a way forward of sustainability, is actually how can we have a little bit of working from home and preventing people to actually commute, but still keep some sort of social presence. And maybe the digital twin might just provide a way to have a day in the office and then a day at home working remotely, a little bit a better experience for that.
Amazing. We could absolutely use that in Kerry. A day to work from Kerry. We'd love that. Professor Rozenn Dahyot, that was fascinating. I found that absolutely fascinating because it touched across so many applied projects. Thank you so much for your time. A big thank you to everyone in the audience that sent in their questions. We're going to take a short break now, so we will be back at 3 p.m. with our next speaker, who is Professor Rozenn Dahyot from the University ULEV in Quebec. We'll see you all again shortly. Thank you so much, Rozenn.
Thank you. Thank you very much.